Bonjour and namaskar. Morphing Machines is a silicon and software IP company based in Bangalore in India. Today I shall tell you the story of Redefine from Morphing Machines. Do you know that your smartphone uses more energy than your refrigerator? And that 2 internet searches use enough energy to make a cup of tea? Today we use 1500 terawatt hours a year to power information and communication technology on the planet. This could very well double within the next 10 years, and over a half of this energy is used by processors. Processors in our devices today are more powerful than ever, but user applications are becoming mere user interfaces to humongous software applications running on the backend servers in the data centers. The data center itself is a huge maze of CPUs, GPUs, disks, and networks, and so on. So a single multi-core CPU or a GPU could burn 100 watts. We are talking about billions of these processors all over the place. And most of these are powered on pretty much 24/7. So how did high-performance computing or high-performance processors land in this kind of a situation? So there are 2 canonical ways of HPC that are prevalent. First, parallel computing. So independent subtasks of a computation are executed concurrently, as done in multi-thread software running on CPUs or GPUs. Second, custom hardware acceleration. So results that could require executing a couple of thousands of instructions on a general-purpose processor could be produced much faster by custom silicon designs meant for that purpose. So things like algorithmic performance on specific applications of interest, ability to customize and specialize compute capacity to particular application needs, minimizing power usage, these things receive much lower priority than they should. Each of the 4 major categories of compute platforms today suffer from major limitations in multiple ways. And there is an urgent need, we believe, for a new processor architecture to rescue HPC from this blind alley. Ladies and gentlemen, I present to you Redefine, a reconfigurable massively parallel processor architecture for extreme high performance computing on system-on-chip solutions. Redefine supports multi-level power management. It scales from 64 to 4K processors on a single SoC. It supports custom hardware acceleration, and it reconfigures compute capacity dynamically to suit exactly the needs of the acceleration, the compute kernel structures in the application currently executing, and is done at runtime dynamically. This is how Redefine looks like in a schematic manner. And as you can see, the massive parallelism is quite evident, and the customizability of Redefine comes from having custom function units which can be embedded inside the processor cores. The scalability is huge, as I mentioned already, and the reconfigurability comes from orchestration by compiler orchestrated execution of application substructures on the fabric dynamically on a runtime basis. So powered by parallelizing compiler technology, which is specific to Redefine, Redefine performs superbly on applications of all kinds which involve extremely compute-intensive applications. And a few of those which we are interested in right now, together with our customers, are some of the things that you see on the top of this list. The market for reconfigurable and many-core processors will be over $10 billion by 2020. And I'm very happy to tell you that right here in Paris, one of our most important global international customers is busy exploring how Redefine could make a big difference in mission-critical avionics applications. We are raring to go forward. I mean, we are a semiconductor company. We have not made a chip yet, and we are raring to go forward to make the first Redefine prototype ASIC within a year from now. This is where Redefine is going to go. And the quest for Redefine brought together a group of veteran computer scientists, computer architecture researchers, software researchers, and entrepreneurs like ourselves, together with some of India's brightest young graduate students in computing at the Indian Institute of Science at Bangalore. And this is what we are going to do together today. Our mission is to be the world's top provider of customizable, reconfigurable, and scalable massively parallel processor technology in the world. It will apply for both high performance as well as embedded computing. And that's what Redefine is all about. Thank you very much.
You were talking about legacy systems that you said were difficult to recode, and so that this could actually solve the problem. Could you just explain a little bit? Do you need to go into multi-core programming to use your processor, or how does it work with the software layer, basically?
I'll take you back to this. So one of the things which I mentioned already earlier, that one of the things that nobody wants to do is to rewrite things that already work, existing code. And one of the reasons why, GPUs suffer from two kinds of problems. Redefine is the closest comparable thing to the GPUs, although the architecture is very different. GPUs are shared memory architectures. Redefine is a message passing architecture. It works based on a network on chip, and all communication happens over the network. There is no shared memory in the Redefine processor. The major problem with GPUs are two. One is, of course, the power, which is killing everybody. I mean, it's killing the planet. Secondly, it requires complete recoding of the existing applications. So if today we have a C program application which runs on existing processors, if you want that ported to the GPU, you rewrite that in CUDA or in OpenCL or some such, and that requires significant re-engineering. The same thing holds good for FPGA-based solutions or other solutions. In case of Redefine, the Redefine compiler works in two different ways. So we are now working on how the parallel programming model is going to look like in the Redefine compiler. But right now, the Redefine compiler takes sequential code. It will take existing sequential C code and then create the necessary parallelisms that are inherent in that code, and then convert that into the way of execution that you saw in this picture over here. So the reason that this works is that there is a lot of fine-grained instruction level and task level parallelisms evident in even existing C code. And even without doing a single line of code rewriting, it is possible to extract that parallelism and make it manifest on the platform on which it's going to execute.
So it's by compiling differently?
Yes. So that's the beauty of the Redefine compiler. It's a parallelizing compiler. It's based on the LLVM infrastructure and then builds special optimizing layers in the optimization middle layer and introduces the restructuring of the application for concurrent execution at runtime. And this entire thing is dynamic. So another way of looking at this would be to think about comparing Redefine with, well, I wouldn't take a name, but you could think about the typical SMP multi-core processors that you know today, which are there in all our devices. So they have a fewer number of cores and much larger granularity cores. And that the way, what we're trying to show in this picture is that by means of being able to create these virtual cores which are dynamically formed at runtime to allocate to a particular subtask to be executed, we're able to create dynamic, heterogeneous virtual cores on the fly and give them away when they are no longer required. So the same execution scenario with, let us say, 7 subtasks as seen in this picture might look something like this. And the other handicap here is that, although a subtask might be very small and it could require a very little amount of resource out of this huge code on which it's executing, but you are actually burning power in a large part of this, the remaining part of the processor code. So in our case, we not only are able to pack tasks more nicely into the execution fabric, we are also able to do very, very aggressive power management, because anything that is not used on the fabric at any instant can be instantaneously powered down.